Hi, it's Chris Dixon. This is the a16z podcast. I'm here with my partner, Peter Levine, who, so Peter, you focus a lot on data center technology, sort of when people talk about the cloud, what is this cloud? Someone has to build it. It seems like it's an exciting time in that area. Like, can you kind of explain why?
Yeah, it sure is. And I'm Peter. Hello, everyone. It really is an exciting time. You know, data center, which tends to be the plumbing of the internet, has been one of these pretty staid areas for a long time. And all of a sudden, there's been this unlocking of lots of innovation happening in the data center, largely on the back of, and not uncoincidentally, on the back of the whole mobile revolution. Like, as every human on the planet starts to use a mobile device, you know, tweets and emails and applications, all that information has to go somewhere, and it goes to back-end data centers. It goes to the cloud, and the cloud is comprised of data centers and computers, and that whole infrastructure is now transforming to support massive numbers of users that are out there, and eventually Internet of Things to support all the endpoint devices that are out there.
Can you kind of explain, just like, so in the old days, or whatever, 5 years ago, if you would go as a company and you would rent space from Rackspace or whatever, some physical data center, you would install your own servers, you would buy software, you'd install it there, like Oracle and all this kind of software, right? And then what happened is people started sort of use Salesforce, and they manage their own data center because software as a service is the first enabler, right? And then what you really had then, these giant scale companies like Facebook and Google, who had such a new level of scale that no one had ever, they had to actually design new infrastructure, right? And so can you kind of explain like how that has evolved?
I think it's tremendously interesting what Facebook and Google and Twitter and other very large scale-out companies are doing. It's really interesting because it's the consumer internet companies that are driving this back-end infrastructure.
Because they have to.
They have to, right? I mean, they're supporting billions of users. This whole notion of multi-tenancy, you think about all these users, they're all kind of, you know, independent.
It's kind of crazy to think Facebook is more sophisticated on networking right now than Cisco, right? I mean, is that fair to say?
Yeah, it's very fair to say. I think Facebook and Google have absolutely pushed the needle on back-end data center infrastructure. And it's interesting. It's all about software. It's about commodity components kind of being put together in these data centers. So it's much less about thinking of a big vendor coming in with a refrigerator-sized switch or storage device. It's much more about aggregating very inexpensive components at massive scale using a layer of software on top that can unlock the value.
So in the old days, you would go to EMC for your storage, and they make a custom piece of hardware and software. You go to Cisco for your networking. You'd go to HP, Dell for your
your servers. You'd go to Oracle for your databases.
And all of those custom hardware. Now people are saying, no, let's just take completely commodity Linux, and it's all software.
Absolutely. We like to say the mobile supply chain is eating the data center, right? And it's rather interesting that, as you know, look, mobile, the innovation in mobile and the innovation in hardware on mobile devices has been phenomenal over the past several years. We will be able to take many of those, and Facebook and Google are setting an example here, to take many of those components, whether it's ARM chips or flash memory, and take those hardware components and aggregate those together with open source and proprietary software to create the next data center of the future.
So my smartphone is connecting to the cloud, and the data center is literally going to be a bunch of reconfigured smartphones.
That's a great look. I have this visualization that the data center is 1 billion smartphones connected together through very sophisticated software, and it doesn't, you know, may not have a screen on it or whatever, but it's
well,
it is
things like,
those,
for example, ARM processors. It turns out that power is the most important, is the scarcest resource in data center, the same way that it is on the handset.
Power and cooling are critical elements in designing a data center these days. So to the extent that we can go design a data center that uses much less power, requires much less cooling, is optimizing on floor space, those are the ingredients for massive scale-out data centers, and those are the drivers. So to the extent we can use mobile components for that, it's definitely going to solve that problem.
So how does this then relate to our investing? So, you know, I know probably what a quarter, maybe even a third of our investments are around data center technology.
Yep.
Can you kind of walk through like different areas of the storage, networking, compute?
Yeah. So on a broad level, if we take Facebook and Google, those companies are becoming the blueprint for data centers of the future. It used to be where companies would look at Wall Street, for example, at Fidelity and Morgan Stanley and say, hey, we want to copy, we're going to build a data center like them
so
now.
Fidelity would build something and maybe some of it would be custom. And then companies would come along and say, let's take that, factor it out and sell it to other people.
And right, companies would come exactly.
Startups. That was a startup
would go look at Fidelity or Morgan Stanley and go build a stack of.
So in the old days,
things.
if you were an entrepreneur looking to do a data center company, you'd go and learn what Fidelity's doing, package it up as
merchant market products to make it available to the rest of the world.
Today, you would go look at what Facebook
and now you go look at what Facebook's doing and Google's doing, and you say, okay, instead of me as a company having to need 10,000 engineers to keep this up and going, how can we create the merchant market products to make that type of data center available to data centers around the world, to companies around the world who want to go build this next generation of system infrastructure.
Yeah.
And so a lot of the companies that we invest in, whether it's storage, networking, compute, databases, analytics, security, all follow the model of how do we unlock the value of commodity hardware components with sophisticated software to bring this next generation scale out data center to everyone who's building that.
So maybe we can talk about a few of these companies. So like on the networking level, Nicira was a company that we invested in. Can you explain what they do?
Yeah, so Nicira, a company that was acquired by VMware, they really pioneered this whole notion of software-defined networking and really unlocking this sort of hard coding of networking to something that's much more flexible. Anytime you build something in software, it becomes inherently more flexible. So they unlock that.
And what's the customer benefit of that?
The customer benefit of that is that no longer am I locked into particular silos of networking or having to lock down a server to a particular underlying piece of storage or a user to a particular server. It's very fungible. And so if I'm creating a service-oriented architecture, I need to be very flexible in terms of how my network connects to different parts of my physical infrastructure, and that the software layer actually enables us to go do that. So Nicira is now part of VMware, and VMware is taking that to market. We are, on the networking side, one of our current investments is Cumulus Networks, which is building very much along the theme of replacing network switches. What they are doing is taking commodity hardware, putting a layer of open source and closed source software on top of commodity servers and turning that into a new switch that is as fast as as capable as some of the most proprietary systems that are out there today from the likes of Cisco and Juniper.
And then what about storage?
So on the storage side, we see much of the same thing, where, again, it's all about software being built on top of commodity components, whether it's flash or flash has become a huge trend in storage. Well, unlocking that flash and using commodity flash as the basis of an enterprise storage array is quite compelling for the market, to the extent that we can build, take software and unlock the value of commodity flash. We can literally see in the not too distant future the cost of flash storage devices being the same price as spinning media, and that's going to be very compelling. It's fast, it's reliable. So I think that the transformations on that side are really interesting as we start to use, again, these commodity components for the basis.
Why
of the
weren't
systems.
people using commodity components, let's say 5 or 10 years ago? The performance wasn't there. Is it just one of these sort of Moore's Law things? Where
so one could argue that we did use commodity components. You had mainframes. Mainframes were replaced by PCs. So 5-10 years ago, it was the PC revolution. So x86 chips and disk drives from a PC and Microsoft software and Oracle data. That was quote unquote commodity. Commodity now is even way more commodity, in that in the same way that PCs replace mainframes, I see mobile devices replacing PCs. So it's really, 10 years ago, people were talking about commodity components in the data center, meaning x86 and PCs. Well, now we take that a step further, power, cooling, the price of these components coming down that much further. It's just the further commoditization of enterprise hardware that is continuing.
And so what? And so how do you think the world's going to look in 5 to 10 years, in the sense of, is every large company going to be building their own data center using the software? Are they going to be outsourcing it to AWS and Amazon and Google, like the stuff that we're seeing now with like every startup we meet, right?
Yeah,
it would be strange to not be running your stuff on AWS.
Yeah.
Is that how enterprises are going to look in 5 to 10 years?
Look, I think a lot moves to the cloud. I think there's the big debate of, does everything move to one?
But there's sort of private or public cloud, right?
There's private, there's
private cloud is Goldman Sachs has their own quote cloud.
Right. So I think certainly the notion of private and public clouds will be the dominant compute sort of style in the future.
So there won't be a question as to whether you do a cloud, quote unquote, cloud style infrastructure. The stuff we're talking about, it's so much better. But it'll be a question as to whether you own it and control it.
Correct.
And that will be mostly around security.
Security, data, kind of
regulatory
within,
stuff, like HIPAA and whatever.
All of, and so, sort of DNAs of the company themselves on how they view this. But every data center of the future will be a scale-out data center, right? Applications are going to change. The user base is going to need that as, again, mobile. And then we start to think about Internet of Things as, collecting all this information and analytics that needs to be done on that, all point to this notion of the scale-out data center, whether it's public or private.
I see. So you think it'll be, and the difference will just be, as you said, depending on the DNA of the company, or maybe some security issues or something, but there's not a whole lot of there won't be other reasons why you would go private, or?
I mean, on-prem, private. This is it's certainly if you have a private data center right now on-prem, I think it'll take a while. So a lot of people will say, well, of course I'm going to continue to do that. I think that the economics and the way that data centers are going to be built is going to drive everyone to private or public clouds, and the notion of the on-prem data center starts to disappear. But, we'll see what happens.
And you mentioned Facebook and Google leading the way. Amazon's not leading the way? I mean, that's most people think of cloud, they think of Amazon.
I think that the Google and Facebook infrastructure is now, in my opinion, more advanced than what Amazon is. Amazon was created many sort of already generations ago, relative to this commoditization curve.
Can you give some examples of the kinds of things they do that are old technologies? Like virtual machines, for example.
I think, that's a good one. Yeah. Amazon, from what I know, is based on a virtual machine architecture, and virtual machines were the way to encapsulate information and encapsulate sort of data. I see that we've already moved to the next generation where virtual machines, certainly which is containers, which certainly in a Google or Facebook environment, it's more about containers and less about virtualization. Now, why is that? Well, containers use far less compute resources. It used to be where I had to support Windows and Linux on a machine, therefore virtual machines are important. Now it's only Linux on both sides, Linux as the base operating system and running within these containers. So we can simplify the environment by, as an example, through containers, and that unlocks a lot of additional power for compute for applications, as opposed to locking that power down for the virtual machine infrastructure.
So what are the areas in the data center that we're looking at for new investments? Like, what do you consider the
one of the new investments that we recently made was a company Mesosphere, and I'm particularly excited about that particular architecture, and that it literally is what I call the 1 over VMware technology company. And when I say one over VMware, this is not about carving up machines and carving up resources. It's about aggregating resources together. And I think that the notion of aggregation of processes, compute resources, storage, and bringing that all together against this massive scale out kind of data center is going to be the way that environments run in the future. So that's one area.
So I think of it as, so tell me if this is wrong, but I think of it as so in the cloud architecture, the data center becomes a lot like a server used to be, and therefore a single server. So now the entire data center is in a sense one server, and all the things you used to do at the server level in the operating system are now need to be done at the data center level. And I think of Mesos as sort of like maybe the scheduling aspect of the operating system.
But it is a platform for the aggregation of these resources beyond just scheduling. So one could imagine applications actually being written to the Mesos API, and it will coordinate the right resources from the right places coming together, not unlike, an operating system does on an individual server.
So you can say, I want, to increase the capacity of web servers 50% and databases 10%, and it'll just
and Mesos will go out and get that for you and make it available to the application, and you can just, without the user doing anything.
And in the old days, you had to have like a team of sysadmins, spinning up servers and configuring.
And your analogy of like single server to data center being the server is exactly the analogy. Within a given server, I could always, I could tune things up and move things around. But at the data center level, very, very difficult to do. And then things change, and it's, sort of a shit show of stuff that goes on, and it's crazy, right? And so as you expand out to thousands or we talk about 1 billion cell phones. Imagine trying to manage all that without something like a Mesos helping to coordinate it all.
So what other areas do you think are, that we haven't made investments in yet that you think are interesting?
I'm interested in, I think the whole container world is particularly interesting.
So containers, let me do my layperson's take on containers too. So virtual machines, if in the data center world, have probably been one of the biggest inventions of the last 10 to 20 years.
It's at
VMware, massively successful company that pioneered it. It basically allows you to run an operating system on top of an operating system, which is great for both running Windows on top of Linux, but also in a way to partition resources effectively. So you can say, it lets you change things in software that pass you to change in hardware, like you want to run more web servers or something. But the problem was you're running an operating system on top of an operating system, which is a preposterous architecture, right? It's just
it's
a total hack. It's a kludge. It's a kludgy hack.
It's a complete replica. That operating system, the base level operating system is a complete reproduction of the server itself.
It's Inception-like, in that everything is
that's
happening,
why it's virtualization.
A dream within a dream, and it's
just
incredibly resource intensive.
It's very resource intensive. Now,
so containers you get the benefits of that, but you're not doing a dream within a dream. You're doing one layer of operating system.
You're doing one dream, right? It's sort of one layer.
Yeah.
The operating system effectively reproduces itself, right? So you have multiple instances of the same operating system running on a system. Yeah. And look, I think the notion of the notion of having a container and being able to move things, and this was the best of the virtual machine world, was that I had this entity that I could move around, and
this is like so a developer now. What happened also, right, is in the old days you wrote a program, right? Now you write a program, you got 50 different libraries, you've got a database, you've got a web framework, and just getting the thing deployed. So you take your software now, want to put it on a new machine, is like a day of work of downloading, configuring, installing.
Yeah.
And so containers let you package it all up in one single file, and boom, you can shoot it out anywhere you want.
So, and that is the value.
Deployment is amazing with
So for virtual machines, that was this, had similar characteristics.
Yeah.
One file I could go deploy in multiple places. Containers offer that without all the overhead of this virtualized infrastructure. And so I think that's
one
really...
of these, it's a rare thing where it just seems like it's a no-brainer dramatic improvement over virtual machines, and they're just VMs are over. It's going to take a while.
It certainly will take a while.
But there's not really trade-offs here. Right?
The trade-off in the past was, and I mentioned this before, is that what virtual machines allow you to do is run different operating systems on top of the base operating.
That was a big.
Anymore. It doesn't matter anymore. So while it's a
Linux is so people don't understand. Some people don't understand. It's so thoroughly one.
It's pervasive,
just,
right? I mean, it's one. And so if I happen to be running Linux on top of Linux, like, hey, that's just fine, right? In the quote unquote old days, I had to run versions of Windows. I had to run different instances of Linux, and so that mixed environment created the opportunity and rationale for server virtualization.
Yeah, that makes sense.
So I think the world is shifting in this new direction, and it's going to unlock, I think, a lot of value out of these data center infrastructure components.
So around containers, so we have Mesosphere. Like, what are the other interesting kind of startup opportunities there?
Around
mentioned containers as being an interesting trend.
So one of the things that I'm particularly interested in is the hosting of a variety of infrastructure components. So we made an investment in a company, Digitalocean, right? Mm-hmm. And what they do is they take a variety of open source components, and they're a cloud for developers. Mm-hmm. And what I find really interesting about their environment is they are offering to developers the hosted instance of many open source projects. So I'm a big believer that we're moving from a world of sort of this on-prem kind of virtualization running on-prem to these hosted instances of, let's say, hosted instance of Docker, for example, or hosted instances of databases. And so I think, in my mind, to the extent that we look to invest in the not too distant future, it'll be about investing in hosted instances of particular open source technologies. So a hosted Docker might be an interesting thing.
And this is partly because it provides a good business model for open source.
Yes. One, it provides great value to the end customer because I no longer have to deploy this stuff on-prem, right? And then the business of open source. This completely rationalizes open source as a viable business model. In the past, open source was a questionable business model. Yes, Red Hat made a nice way at it. I wrote a blog on this. There are some companies who will make good money with open source.
Red Hat was successful, but there haven't been there have been acquisitions, but there haven't been
standalone franchises other than Red Hat that have really been able to quote unquote monetize.
Given the scale of the importance of open source, given that it's if you compare it to its proprietary software analogs, it's Microsoft.
Look, you just made a couple of minutes ago. You made the point that Linux has taken over the world, right? There's no need for anything else. Well, if you think about the economic benefit that Red Hat has derived over the complete transformation of Linux, it pales in comparison to the impact that Linux has had in the world. Yeah. And so, look, open source has been fantastic. It's been a fantastic vehicle for innovation. But in terms of economic value back to the developer of open source and back to the provider of open source, I believe that once open source can be provided as a service, it is then able to unlock full market value and full potential. And to me, that's a really interesting sort of transformation.
So does that mean the company, historically with open source, the interesting company has been the company that had the core developers of the project? So, for example, MySQL, the company had the MySQL developers, right?
Yeah.
Right? And so, and so in the future, you think that there's a cool new open source project X. The key developers for X will be in a company, and that company will provide a service-based version of that software. That's what you think will be the future of the open source.
Yes, I think that to me is the interesting part of the next gen open source models. Will be that particular type of deployment, and GitHub is a good example of this. They're the epicenter of all open source development, right?
So you could have taken Git and you could have sold it MySQL style, or you could do GitHub, which seems to be a much more interesting business.
Duh, right? Yes.
Okay.
So that model is exactly what I believe is going to happen at every segment of the open source market will be around.
Do you think GitHub, though, GitHub has that network effect?
Yes.
Do the other? I mean, I
Look,
I wonder if it's really the beginning of a pattern or if it's such an exception.
I think, look, GitHub certainly has the network effect of developers, but I would argue that if they had just gone off and supported Git and done it as an on-prem thing with some collaborative hoo-ha on top of it, it would never have been as successful as what it is now. So sure, the collaboration adds to it, but look, I mean, I think, there are a number of companies who I believe will have very great promise of offering sort of the SaaSified versions of open source that will be the future, just because it's going to be very compelling for them to continue to innovate and for users to actually use that in ways that we just haven't seen before.
Okay. All right, great. We're out of time. Thanks.
Okay, thanks.